till now we have discussed about water content, void ratio and porosity. So today we will discuss about degree of saturation, so what is its importance, and air content and percentage air voids, that is Na. Air content is denoted by A suffix C. So first we will start with degree of saturation. So degree of saturation. So degree of saturation is denoted by capital S. Degree of saturation is denoted by capital S. So it can be defined as the ratio of volume of water to the volume of voids. Volume of water to the volume of voids. Volume of water to the volume of voids. Now when you see about its limits, then S is equal to what in dry condition, and S is equal to what in saturated condition. So when you see so in dry condition the volume of water will be 0. In which condition? In dry condition. So when the numerator is 0, then obviously the degree of saturation S is equal to 0. So this is the case in dry condition. In dry condition the degree of saturation will be 0. But what happens to saturated condition? Saturated condition means all the voids which are present in the soil are completely filled by water. That means when you come to saturated condition, numerator will be volume of water and denominator volume of voids are already filled by water. So this will be also equal to volume of water. So it's equal to 1. So the degree of saturation, which is the ratio of volume of water to the volume of voids, in dry condition S is equal to 0. In saturated condition S is equal to 1. Now there will be one relationship, so that we will discuss. So till now we have discussed only degree of saturation. So next definition. So next definition will be percentage air voids. Percentage air voids. So percentage air voids, it can be denoted by N suffix A. So Na, which is equal to Va by V. So how much percentage of air voids which are present in the total volume of the soil, that can be given by this term percentage air void. So how much percentage of air voids are there in the total volume of soil. So when you want its limits, minimum limit and maximum limit, so what I have told in the first video, for determining the minimum limit and maximum limit, we have to assume the dry condition as well as the saturated condition. For example, in the saturated condition, all the air voids are occupied by water, so it will be 0. And will the numerator will be equal to denominator? In any case it will not be possible. When you take a dry condition or a saturated condition, the numerator will never be equal to denominator. So that is why it is less than 1. So air voids lies in the range of 0 to 1 including 0. So this is what about percentage air voids. Now we will discuss another definition, that is air content. Air content. Air content. It is denoted by A suffix C. So it is denoted by air suffix C. A suffix C is equal to VA by VV. VA by VV. So VA by VV. So the maximum limit and minimum limit will be 0 less than or equal to AC less than or equal to 1. So in dry condition, what will happen? Only air will be present. So numerator and denominator will be equal to 1. In saturated condition, the numerator will be equal to 0 because air voids will not be there. So that is why air content minimum limit is equal to 0, maximum limit is equal to 1. It lies between 0 to 1, including 0 and 1. So that is what about air content. Now we can derive some interrelationships between this degree of saturation, air content, and percentage air voids. So this relationship between degree of saturation, NA percentage air voids, and air content. So S is equal to volume of water to the volume of voids. So both sides, if we subtract 1, then 1 minus S is equal to, what will happen? VV minus VW. So volume of voids is nothing but volume of air plus volume of water minus VW by VV. So this is cancelled and this will also be cancelled. So 1 minus S is equal to VA by VV. So this 1 minus S is equal to, so we have already defined VA by VV is nothing but AC, air content. So we can write S is equal to 1 minus AC. So this is the relationship between degree of saturation and air content. This is the first relationship, and one more relationship is also there. So that is, so from this also we can define S is equal to 1 minus AC, that is one relationship. So by taking S is equal to 1 minus AC. So 1 minus AC is, this is equal to volume of water to the volume of voids. So 1 minus, this will be nothing but VA by VV. So VW by VV is equal to 1 minus VA by VV. So this will be equal to VV LCM. So VW by VV is equal to VA plus VW minus VA by VV. So this VA will be cancelled and this VA will be cancelled. So it is satisfied. So there is no change in the relationship. That is okay. So next one, that means whatever we have derived, so that is satisfying. So we don't need to bother about much. And next one, AC is equal to VA by VV. So multiplying and dividing with volume, multiplying and dividing with volume. AC is equal to, so VA by V into V by VV. So we know that VA by V is nothing but percentage air voids, Na, into, so this is like void ratio is equal to VV by V, but here it is written as V by VV, so that is nothing but 1 by N. So we can write Na is equal to N into AC. So here two relationship we have derived, so those are nothing but so S is equal to 1 minus AC. This relationship we have derived, and once again we have cross verified also whether S is equal to 1 minus AC or not. We have cross verified. So Na is equal to N into AC. So percentage air voids is equal to porosity into air content. S is equal to 1 minus AC. So this is what about degree of saturation, percentage air voids, and air content. So the definitions we have discussed, and the minimum limit and maximum limit we have discussed. So in the next video I'll be discussing about different types of unit weights and their importance. So that the unit weights portion will be covered, and from the next lecture we can derive the interrelationships between this volume and water, the interrelationships, what is the relationship between them, and around 12 to 13 formulas will be there. Those formulas will be very much helpful in solving the problems. So this is what about today's lecture. So for more videos, please subscribe to my channel.